all, good afternoon. Thank you very much for taking time and joining here. I want to start with a question. How many people attended the panel discussion yesterday on smart application? Cool, okay. So, just an extension to the smart application panel, and here I am going to talk about a very early concept that we kind of started this year. Called self-guiding application. And before I get started, I really wanted to thank one of my intern, Haubo Chief. He was one of the guys who joined us in summer and kind of got some of this vision to reality. And then, of course, Himen is going to do a demo of what we have come so far. So yesterday we had a conversation around smart applications. And I did briefly mention that our vision was around a self-guiding application. How do you make an application that automatically guides itself? And why are we trying to do this? We have noticed that many of our applications are becoming more complicated. The user experiences are becoming more difficult. We all have an inherent pattern of using applications. I have noticed that there are certain actions that I perform using my computer, and when I see my daughter doing the exact same thing, we have a completely different pattern of using the computer and the software, but we eventually end up with the same exact result, right? And also we are living in the world of instant gratification. I think the amount of patience I have to learn a software, I don't think my children have that. They just want to get things done faster. So our thought was, how do we make a complex application or a complex user experience more self-guided? And here are some examples, especially in case of mobile. We install a lot of mobile apps on our phone, and the moment the user experience is not good, we try to uninstall them and go for the next one. And we also wanted to tackle the mobile experience as our first use case to just see whether this is even a feasible idea. And in mobile, we know that the complexity of the app, the screen size, it all limits the user experience overall we can get. So, our objective was really to provide the best customer engagement experience that is possible using crowdsourced data or crowdsourced product usage data. And so that was basically our intention. So here is an example of an application. It's a very simple photo editing application. It has around 19 actions. And if you see that there is a menu panel, and then there's also a contextual panel. And the moment you install the app, you launch it, pretty much everybody is going to get the exact similar user experience. Even though the application might have some inherent knowledge about each individual user, the navigation is not going to change, right? Our thought was, what if we are able to mine the user behavior and usage patterns of the past users and able to segment users and try to predict the next action or try to predict the most appropriate menu actions that should be visible on the screen rather than you scrolling around to see where is that particular thing that I wanted to do. So that was basically one idea that we had to provide a predictive feature panel, which is the menu icons, and also to provide contextual menus. For example, when you take a picture and you look at it and the picture is blurry, the immediate thing you do is you take another one, right? But sometimes the moment is passed away. Or you take a picture and there is red eye in the picture. Most of the time you basically decide that, okay, I'm going to fix it later. It usually never happens, right? So our thought was, what if, based on these actions, we are able to immediately provide contextual menus and say, hey, you have a red eye on your picture, do you want to remove the red eye? Or you have a blurry picture, do you want to remove do a de-blur action on it? So these are some of the ideas that we had specifically from a mobile use case. And here is an example of a desktop application where, loaded with icons and menus and settings and options. And here our thought was, how do we provide next action based on different color gradients. And the idea was that we are trying to provide the most probable actions that are taken by most of the users of a particular segment type or a particular persona type. And the intention was that we should be able to identify those kind of patterns and behaviors. So you can see that in this example, that assuming the user is in the screen, we are trying to provide the next best actions that we are predicting that you might be able to take, or most people have taken, but definitely you have a choice not to follow through. So as a proof of concept, a simple mobile phone photo editing app, it's relatively less complicated. As I mentioned, we tried it with 20 actions. It has a constrained space. There is a ribbon scroll and also searching for actions. And the goal was, how do we minimize the scrolling action? How do we minimize the searching action? And how do we automatically change the navigation menus and provide contextual menus? So to start with this proof of concept, we went with this crowdsourced product usage data. There's a lot of product usage data that we were able to collect based on past user behaviors. And what we have inherently noticed was that there is usually a pattern of workflow that every user performs when they have a particular action or activity to do. So, every single row, like 1, 2, 3, and 4, these are basically different users performing different actions. And we basically have hundreds and hundreds of thousands of rows of different workflow patterns and behaviors. And each row is a set of action, like a workflow performed in image editing session. And every single icons and menus, we kind of coded them with different action IDs, like 001, 002. And of course, for a data science experiment, we kind of split our data into 80% for model generation and another rest of 20% for doing testing. Our experiment basically went towards different machine learning algorithms. We applied a Markov model, which is next action is primarily dependent on only the present action and not on the sequence of previous actions. We also experimented with N Bayesian model and then an action neural network model. And some of the results that we had was pretty much very close from a next action perspective. And one of the models that we kind of moved forward, or planning to move forward, is basically the three action neural network. And the reason we picked 3 action was, at least in this particular use case, we only have 5 icons or 5 menu items that are kind of visible on the screen. So we wanted to see, do a A/B testing to see if the first 3 actions, we are making it more predictive and dynamic, whereas the other 2, we can keep it constant. And we really had a really good prediction output from it, around 80 to 90%. We were able to get the next action prediction. The next challenge we really had was, how do we get this model exposed as an API that this mobile applications is able to consume? And this is where we started evaluating H2O. We also evaluated a couple of other solutions in the similar space where a particular model gets exposed as an API that could be consumed by multiple mobile applications. And one of the objectives we really had was, how do we loosely couple the model creation and the consumption pattern? So we basically had a data science team, a deployment team that deploys the model in the cloud, and then of course the UI team that, or the mobile application development team that builds mobile apps. How do we keep these different teams independent, but at the same time continuously provide a more consistent pattern of behavior? So continuous model development and deployment capability was one of the things that we really wanted to go after. So this is where we use H2O to create a Java POJO for the predictive model, wrap the entire POJO in our Java development framework, and basically it integrates with some of our platform much more seamlessly. So here is a quick overview of how this entire process works for us. It's a REST API with H2O, training data set, and basically getting deployed and called through the mobile and desktop apps. And with this, I am going to show how far this has come. Heman is going to go and do a quick demo of this application.
Okay, thanks, Venkatesh. So I'll quickly jump into demo. Oh, wow, I have to operate it from here. Okay. So this is not the production-ready code, but oh, wow. I have to. Okay, so just as Venkatesh mentioned, right, this is the data set. As you can see, like it's a small CSV file which is with all the actions separated by a comma. And what we are doing is basically taking this into R. I'm just loading it as a R data frame, and I'm applying a sliding window function to break each and every row into sets of like 3 actions, 4 actions, 5 actions. And those are my data frames that I'm generating out here, the 3-action data frame, the 4-action data frame. And anywhere where there are NAs coming in, we are kind of clearing it out so that it doesn't impact the model. Once I have the data frame created in a proper format, all I'm doing is creating a H2O connection and uploading the data on H2O. And if I go to the H2O server, then these are the 3 hex files that I have kind of uploaded. Basically, it's nothing but the data frame that I have processed in R. And once kind of we have that, I'm just calling the deep learning method to operate on the 3-action, 4-action hex data that I have just uploaded. So this is just a very small hack that I kind of got some time back. As you can see, most of these things was done just about an hour back or so. So these are all the models that I get. And if you kind of quickly take a look at one of them and let it load completely. And where is the scroll bar? Wow, I can't even see that scroll bar. So as Venkatesh mentioned, right, we are not interested in usually a classification type of a predictive scenario. We are interested in identifying how accurate our algorithm is in accurately identifying the next class. But in our case, we are not interested in identifying the next class. We are interested in identifying, is the class in the top 2 or 3 or 5 items that are returned by the model, because we actually want to display 5 items in the scrolling panel down below. And if you kind of take a look at like the 5th item, most of the times we are seeing a very high accuracy in terms of ensuring that the action is in one of the 5 items. The intent is we do not want people to scroll left to right all the time when they are operating on an image. Right now, this is only taking into account the user actions, but as Venkatesh mentioned, we can also add user profile information in case different types of users take different types of actions on a certain type of image. Also, an image has a lot of properties in terms of EXIF data, its own histogram, and that also could be used to suggest the next action. So right now, it's only kind of limited to the user actions. So that's how this model looks. And if I kind of come back in R, once my model is created, I can very quickly know what its name is. From basically, the name of the model is going to be, wow, I have to scroll from here. This is basically the name of the model key. And what I can do is, just give a simple curl command, get the entire Java Pojo. Now what I'm doing, all this can be automated in a shell script. So now you have your entire Java program created out here. I can use simple sed and awk to replace the name of the class to what I need, because the string is kind of dynamically generated. So usually I want to name my 3-action neural network. That class should always have the same name, because once my Java model is downloaded, I would want to wrap it around a web API. So I would need a strongly typed class. So once kind of my Java Pojo is downloaded, all I can do is, this is where I'll kind of put it. So basically, this is the renamed Java file. What I just downloaded, I have just renamed it from deep learning underscore that hash to deep learning underscore 4action. And similar name change needs to happen in the name of the class that is there in the Java file. The moment that is done, all I can do is I can create a very simple wrapper like this, create a API to wrap this intelligence into an API. So let me just quickly run it through. Is the mouse gone? Wow. You can't see where the mouse is. Oh yeah, there it is. And if I kind of quickly run it through, so as you can see out here, this intelligence is now being exposed as a web API on this number port, 4567 on my local machine, and I can very easily call it through. So 127.0.0.1, 4567, next action. So if I kind of hit this, and the current actions that I'm taking are 002 and 008, and what it returns is the list of action in the decreasing order of probability. So after 002, 008, the highest probable one is 009, with a 32% chance of somebody clicking it, and so on and so forth. So that's how kind of you can play with it, 012. So this would call the 3-action network, and that's how kind of it works. So this is a very kind of quick way to mine the intelligence from huge amount of data that you would have on-prem, generate a 1 KB or 2 KB model, the intelligence, and deploy it over the internet by wrapping it into an API, which is something which H2O helped us solve, that challenge, which we were not able to solve using R. Okay, that's a quick demo.
Yeah, so our thought really here was to come up with this notion of smart application, and how are we going to help some of our complex application to become much more simpler and much more predictable. And our thought here is that as we are able to learn the product usage behaviors more and more, most of the user experience design could just become more and more intuitive and more personalized. And so basically this is our first proof of concept from an experiment perspective on trying to figure out how we can kind of enter into this concept of smart applications. Right. So with that, if there are any questions, we'd be happy to take.
My question is here. When you generate the Java code from the H2O, they should have the input parameters for the Java code. So how your new app to fit into the parameter of that Java code to apply the new data?
Apply the...
Okay, so is your question, when I'm calling the API, how is that information going into the Java class to generate the result? Is that your question?
Yeah, so I assume that when you get the Java code from H2O,
yes,
the Java code must have the input parameters.
Correct.
Right, and output parameters.
Exactly.
So how a new application that's going to use that the model to fit in the input parameters?
Oh. So you saw that the model was created, right? It's there in H2O. I can use a curl command to download the Java file. Now let me go into the code. Out here, when I'm calling this API, you see that there is a next action switch out here, and post that I'm passing all the arguments. Okay, this thing comes out here in app, and let me minimize this. So here the arguments kind of come out here in cur actions, and I'm parsing out cur actions and putting it into the predictive API. Now predictive API is just a wrapper around that Java class which I have downloaded from H2O. So the string that I'm passing in my browser, it comes out here in the code. I parse it out, fill it into an array, and send it to the Java file that I have downloaded. So that's how those arguments go from your browser to this particular API wrapper, go into the model that I have downloaded from H2O. The output of the model then comes back via the same route, and that's how kind of I'm displaying it out here. So if you see next predictive action using the predictive API, and next probability action list is basically the output of that model, the Java class that I have downloaded, which I am just displaying it as toString.
In case of mobile application, it is the mobile application that is going to keep calling the next action API, and the designer, the application is going to use the output from the model and bring in those actions. So definitely there is an equal amount of work that has to happen on the mobile application as well, or any smart application, where it has an understanding of this kind of a model in the back.
Also, one more option could be that since Android is a Java-based kind of a platform, what you can do is hard bake a base model that you can generate using some base amount of data and hardwire it into your app when it is getting compiled. So that is, so for example, if internet is not available, your application could fall back on that hard-baked model to enable the predictive API, which is there within it. But whenever internet connection is available, it will make the call to the latest model that is available on the internet and make more better predictions. And just because this entire process that I showed manually, you can very easily automate it using a shell script and put it into a Jenkins server, and you can have your model refined every day, every hour, every minute, whatever you want to do.
All right, I think we've got time for maybe one more. Have any other questions? Oh, here we go.
Currently, your model, if I understand correctly, the predictions of your model depend in the recent activity of the user, plus on how an average user would behave given this recent activity. Do you think it would be worth trying to fine-tune the model to the user itself? Yes.
As you mentioned, right now this is just a proof of concept that we are sharing that this is possible. This is one way of designing smarter applications. The hardcore data science part is definitely we can make more and more smarter models, as I mentioned, where you can understand the usage patterns of a particular group of users, which we call the user segment. You can also personalize it to a single user, how the person uses it, and at what point the person is. What is the type of image? All these things are possible, but to explain all this in a simple example like this, we kind of wanted to share the concept, the idea, and how to do this continuous integration. So that's why we didn't, but that's possible.
That would be, I'm not saying that this is something you need to do, but that would be interesting in the sense that if you aim to fine tune it to the user as opposed to the average user, then you have to do things like, recompute the score on the fly and, implement it on the fly. I mean, it would be more complicated, but it may be worth doing.
Yeah, makes sense.
Yeah, our vision really is much beyond this, but we really wanted to share the thoughts that we are going from a direction perspective.
Okay, great. So if we could thank our speakers.